This is a brilliant, capable mind, but it is floating in a void, completely untethered from the gears of reality. Plugging a raw large language model directly into a database produces a wrapper. A large language model, or LLM, is a system trained to predict the next word in a sequence based on massive datasets. These thin interfaces lack the deterministic logic needed to manage enterprise-scale complexity. This document outlines why that approach fails. Notice this section on the stateless execution model. When an AI holds its own mutable internal state, it becomes vulnerable to silent drifts, changes in behavior that go unnoticed because the system's memory has become corrupted over time. Safely bridging advanced reasoning with real-world execution requires a mathematically principled, deterministic operating environment. Adding raw intelligence to an enterprise system without an ironclad governing infrastructure exponentially increases risk. We build from the ground up. This is the architecture for GhostOS, an environment designed to govern artificial cognition. At the absolute bottom, we have the sovereign host substrate, the physical hardware and Linux kernel. Sitting directly on top of that is the GhostOS runtime. These foundational levels mean the system executes commands directly on the hardware. Chatbots generate text that looks like a solution. GhostOS natively executes actual code. By embedding the intelligence engine right into the host substrate, every action taken is a verified system-level operation rather than a hopeful API DES. Moving up the stack, we install the Ghost control plane and the system state fabric. The system state fabric acts as the operating system's self-awareness, continuously aggregating telemetry. Telemetry is the automated collection and transmission of data from remote sources for monitoring. This fabric processes system health without holding any mutable internal state of its own. The Ghost control plane takes that raw telemetry and snaps everything into a rigid grid of infrastructure-grade orchestration. It removes the unpredictable, non-deterministic behaviors common in standard agent setups. This real-time deterministic self-awareness separates a brittle, hacked-together script from an adaptive, enterprise-grade operating system. The fifth panel is the Cognition engine. This is where the artificial reasoning takes place. This engine is restricted. It observes systems, detects patterns, and generates proposals. It isolates a single proposal packet and pushes it upward, shielded from any self-modifying chaos. That packet immediately hits the top of the stack, the governance gate, and finally the user-facing experience shell. This creates an intentional bottleneck. Every action proposed by the Cognition engine stops at the governance gate for explicit human or Council 13 mediation. This is the opposite of experimental autonomous agents that run in unbounded loops, rewriting their own rules until they break their operating environments. True technological autonomy forces every high-level machine thought to mathematically prove its safety before it becomes reality. This document confirms how GhostOS achieves that stability. By implementing zero-proof security, a framework where every action must be cryptographically proven rather than just trusted, the architecture merges advanced pattern recognition with deterministic trust. While the governance mechanisms and audit trails are transparent, the innermost core of the Cognition engine remains shielded. The mathematical thresholds, proposal heuristics, and internal rule logic are classified. This architecture replaces the unpredictability of unmanaged wrappers with the reliability of governed systemic execution. The most successful AI deployments will be defined by the strength of the cognitive infrastructure that holds them in place.